This remote lake in Southeast Asia holds a secret. Miles beneath its placid surface lies the cause of one of the greatest natural disasters ever. More powerful than anything else on Earth.
The devastation that it caused was unimaginable.
All hell would have broken loose.
Its impact is global, but nobody realizes its true extent until a series of scientists working in different fields at different times all chance upon new evidence. A trail of destruction stretching from the Arctic to the equator. This event may have killed millions. It may even have kicked us into an ice age.
It was like flipping the switch on the global climate system from hot to cold.
But what's really scary is it could happen again. A modern-day eruption of this volcano would bring fire, famine and death to millions of people. 75,000 years ago, it changed the world forever. Now, we can show you how. Few of the people here realize their tropical home could affect the lives of the entire world. Lake Toba lies in the northern part of the Indonesian island of Sumatra in Southeast Asia. It's one of the largest natural features of the southern hemisphere and is clearly visible from space. But Lake Toba is also home to a terrifying mystery. A mystery that lurked undiscovered for millennia. It would take the random encounters of scientists working on a range of unconnected research to bring it to light. In fact, the first clue comes from somewhere that couldn't be more different from this tropical paradise. In the early summer of 1988, scientists set out across the frozen desolation of Greenland, looking for the perfect spot to conduct their research. They're here to study the atmosphere and how it changes over time. After journeying across the ice, the scientists find their spot 787 miles from the North Pole. This far north, the ice is so untouched that it contains a record of the Earth's atmosphere stretching back 200,000 years. Throughout history, the chemicals that are in the atmosphere are captured by snowflakes as they form. Over thousands of years, this snow is compressed into layers of ice to form the ice sheet that's over a mile thick. By cutting down through the ice, scientists can obtain ice samples that fell as snow thousands of years ago. When they analyze these samples, they can find out what chemicals were in the Earth's ancient atmosphere. The deeper into the ice scientists look, the further back in time they can go. Climatologist Greg Zielinski helped reveal the secrets contained in the ice. Year after year, findings are as predicted. The chemical levels found in the snow are the same for long periods of the Earth's history. Then suddenly, Greg Zielinski gets the shock of a lifetime and sees something in the ice that defies all logic.
When we got back to about 75,000 years ago, we found a particular piece of ice that gave us information that was just so exciting.
Greg and his team look for tiny chemical fluctuations. But what they suddenly see is a huge leap in one particular chemical compound, sulfate. Without warning, around 75,000 years ago, the atmosphere had become saturated in massive amounts of this sulfur compound. Normally, there is only about 50 millionths of a gram of sulfate per cubic meter of the Earth's atmosphere. But these ice cores showed that at this point in the past, there had been 1,900 millionths of a gram per cubic meter, almost 40 times as much. This much sulfate in the atmosphere would trigger a chemical reaction choking the planet with one of the deadliest chemicals known to man. H2SO4, better known as sulfuric acid. Sulfuric acid is so toxic it can eat through metal. Enough of it in the atmosphere can devastate life everywhere.
The concentration of the sulfuric acid was on the order of 2,000 to 4,000 megatons. That's a lot. That's a lot of material to be up into the atmosphere.
This line on a graph hinted at a global event 75,000 years ago of unprecedented scale. Billions of tons of sulfuric acid had somehow found its way into the Earth's atmosphere. This yellow haze literally cloaked the planet. So where did it all come from? Something extraordinary must have taken place.
The more I looked at the results, I knew we were looking at something that was just cataclysmic.
Zielinski's team know something has happened to the Earth 75,000 years ago. But what? It would take another team of scientists thousands of miles away to answer that very question. Mike Rampino is one of the world's leading geologists. He has long been obsessed with life in the oceans. The amazing thing is, he can work out the entire history of our planet's climate from the shells of tiny sea creatures called foraminifera. During their lifetime, these minute creatures take in oxygen from the seawater. As the ocean temperatures and oxygen levels change, their shells change too. By subjecting these dead foraminifera to chemical tests, scientists can plot the changes in the oxygen atoms within their shells. From this, Rampino can calculate with amazing precision the world's ocean temperatures over many thousands of years. Mike Rampino analyzed data from all over the globe and found that the oxygen atoms in the shells remained the same. which means ocean temperatures were fairly constant for long periods of time. Then, suddenly, a few years into the study, Rampino stumbles on something huge. A point in the Earth's history where the ocean temperatures plummeted.
At the time, I thought, there's something wrong here. This isn't normal. This isn't the way climate usually works. It usually works on a much slower, more steady basis.
Rampino's sea cores were telling him that the ocean's temperatures had dropped 5 degrees Celsius in just a few millennia, which in marine temperature terms is the blink of an eye. Normally, it takes hundreds of thousands of years for the oceans to cool this much.
Temperature change that we saw in these deep sea core records was something like 5 or 6 degrees Celsius. That's 10 degrees or more Fahrenheit. Not over 100,000 years or even 10,000 years, but over just a few thousand years. Now, climatically, that's very surprising. That's very, very fast. That's very catastrophic.
The only thing Rampino could imagine that would bring on this sudden cooling was an ice age, a catastrophic event that could severely impact life on the planet.
It was like flipping the switch on the global climate system from hot to cold.
Rampino calculated the date of this cataclysmic drop in the world's ocean temperatures. It happened around 75,000 years ago, the same time Zelinsky's ice cores were showing massive amounts of sulfuric acid in the atmosphere. Both scientists, unaware of each other's work, researching areas of the world separated by thousands of miles, stumbled across 2 different anomalies linked by a single date. It was a major breakthrough.
I was finding a cooling event at 75,000 years ago, and Greg, I later found out, was finding an increase in the chemistry of the ice cores 75,000 years ago. And we got together and realized that we had the same problem.
When you can look at something from different angles and see the same major result, you know you have found something that was huge, something that was a major force on the Earth's climate system.
The cooling of the planet and the sulfate in the atmosphere might be explained by asteroid impacts. But after comparing their evidence, both scientists feel there can be only one culprit. Occasionally, volcanoes can violently propel this much sulfate into the atmosphere. But for the scientists, there's still a problem. Even the world's greatest volcanoes produce only a tiny fraction of the sulfate Greg Zelinsky had found. And certainly no volcano in recorded history has forced ocean temperatures to plummet this much. The scientists are now looking for something truly exceptional. A volcano hundreds of times more explosive and sulfurous than any yet known to man. This man has no idea he's about to help find the answer.
What's unusual about Lake Toba is its dimensions are incredible. It's 100 kilometers long from that end up to that end over there. It's 30 kilometers wide from the upper rim behind us over to the other side. Another reason is its incredible depth.
For decades, Craig has been trying to solve the mysteries he sees in and around this huge stretch of water.
What we're trying to do out here today with this depth finder is to get a profile of the lake bottom, because by getting a profile of the lake bottom, we can interpret the history of Lake Toba much better. We're starting to get a profile over here. You can see it dropping right off, 23 meters. And that cliff face, it just must keep on going straight down almost.
Most lakes drop away gradually from the shore, but Craig thinks this may not be the case here.
It's 175 meters deep already.
That's incredible for just a lake.
The incredibly steep slopes that drop off from the landscape up above. In some places, the rim is over 1 kilometer above lake level, sheer drops down to the lake, and then as you can see on this profile, it continues down beneath the lake with that sheer drop-off. Some special geologic processes must be involved to form this.
This steep line on the screen is clear evidence that Lake Toba is not just a normal lake, but a huge hole in the Earth's crust, suggesting to Craig that the whole area has some kind of major geological event in its past. But the sheer dimensions of the lake are not the only clue as to its origin. A steep climb above the waterline reveals something else.
Wow, that looks incredible. I need to go get a closer look at that stuff.
Craig is particularly intrigued by the large deposits of ash, which he's finding several hundred meters above the lake.
Wow, there's some really big pummices in this. I can see quartz crystals, I can see biotite, and there's a lot of ash in here. This is all the same stuff. Must mean something really big happened here.
This rock face and the ash contained within it are part of a far bigger picture. Samples like this have been tracked down by scientists over thousands of miles around Lake Toba. But the problem for Craig has always been pinning down how exactly such massive amounts of ash came to be in the area in the first place. The answer to Craig's problem can be found on the other side of the globe. In the summer of 1994, Craig decided to send this man some samples of ash from around the lake. That's because John Westgate is one of the few people on the planet who might be able to solve Craig's mystery. John Westgate is well known for his ability to identify the origins of ash samples. He's the closest thing to an ash sleuth you're ever likely to find. The amazing thing is, if you give John a piece of ash, he can tell you the volcano that made it, no matter where this ash was found.
We try to find out where the ash comes from, its parent volcano. And in that framework, it's exactly like a DNA signature.
Every single volcanic eruption that has ever taken place on the planet is unique. Volcanic ash contains chemical clues of where and when a volcano exploded. Volcanic ash starts life as this: magma deep inside a volcano. During an eruption, this magma races to the surface of the Earth. When it hits the air with enough force, it explodes into tiny pieces of volcanic ash. What our sleuth does is connect a sample of this ash with the magma from a specific volcano and one of its eruptions. When John thinks he's matched his ash to a volcano, scientists go out and take a new sample from the suspect volcano to confirm his findings. The whole sampling process has become a central part of volcanology. Here in Hawaii, where new eruptions are constantly taking place, they do it regularly. At the Kilauea volcano, the magma does not explode into ash, but oozes to the surface as lava. This hot molten rock can be sampled repeatedly by those brave enough to do it. But whatever form it takes, it has preserved within it a huge amount of information that can be accessed thousands or even millions of years after an eruption. For years, John had successfully linked ash to specific volcanoes across the world. But in 1988, a full 6 years before John had ever heard of Craig or Lake Toba, he hit a brick wall.
We start to get boxes of volcanic ash from many different people, and these samples are coming from widely separated parts of the Earth's surface. And when I started to look at this material, look at the volcanic ash, I found that the chemistry was very, very similar.
To John, this just didn't make any sense. Normally, volcanic ash only falls within a few hundred kilometers of a volcano. So how could this ash spray 6,500 kilometers across the globe, stretching from Saudi Arabia to the South China Sea? On closer examination, John found that all these samples had two things in common. Firstly, they were unusually rich in the mineral silica. High silica ash only comes from a highly explosive type of volcano, like Mount St. Helens. What John discovered next shocked him. All these samples spread over a vast distance are the same age. 75,000 years old. It meant only one thing. These widespread samples must have come from one enormous eruption.
So once we realized that it was 75,000 years old, we were able to connect Greg's work in the Greenland ice core because he had dated the sulfur peat exactly at 75,002.
This date suddenly has huge significance. It links not only to Greg Zielinski and his ice core, but also to the catastrophic cooling of the oceans Mike Rampino noticed. Now the three scientists know they've stumbled upon an unknown cataclysm on an unparalleled scale. Now all John has to do is find the volcano.
We started to search for volcanoes in other parts of the world to see if we could find the suitable candidate.
John puts out the call to volcanologists around the world to send in samples from volcanoes they're working on. It's the start of one of the biggest detective hunts in the history of volcanology. One of the first volcanoes they scrutinize is here in Iceland. The Laki volcano is near to where Greg found the sulfate in the ice.
Well, Greg found this sulfur peak in the Greenland ice core, and Laki obviously would be a possible candidate for that, given the proximity of that volcano to the Greenland ice sheet.
Laki erupted in 1783 and produced massive amounts of sulfur. So could it be responsible for Greg's sulfur seen in the ice? Marie Edmonds has dedicated her career to studying the gas that made Laki so destructive.
Laki was a devastating eruption which killed thousands of people, and this was mainly through famine, crop failure caused by the emission of very large quantities of sulfur dioxide into the atmosphere.
But back in his lab, it becomes clear to John Westgate that the composition of the Laki ash is just not what he's looking for. As the search continues, John slowly begins to see a pattern. The ash gets thicker and thicker around Southeast Asia. This region has over 70 volcanoes. But there is one so violent it stands head and shoulders above the rest. This volcano has erupted 7 times in the last 9,000 years, and even created one of the most violent eruptions of the 20th century.
3 reasons why we looked at Pinatubo. One is it was located in the right area. 2, it's capable of explosive volcanic eruptions. And 3, the overall composition of its volcanic ash is very similar.
Pinatubo blew its top in 1991 and subjected the surrounding area to an enormous 15 million ton cloud of superheated ash and gas. Hundreds of people lost their lives and thousands were made homeless. John immediately put Pinatubo under the microscope. During the hours of preparation, John was hopeful. Pinatubo had near-perfect amounts of silica content when compared with the mystery ash. But when he did the analysis, John's hopes were dashed.
When we started to look at the samples in detail, making those comparisons, we found that in detail they clearly are different. So we had to look elsewhere.
Days turned into months. Months into years as John discounted volcano after volcano. Volcanologists continued to send new ash and lava samples to the lab, but to no avail. It looked like this was one mystery not even John Westgate could solve. Then, in the spring of 1994, John arrived at work to find yet another sample. The very sample Craig Chesner had sent John all the way from Lake Toba in Southeast Asia to try and solve his own geological puzzle. John then put Craig's sample under the microscope, and things began to fall into place.
Once we had looked at the samples from Toba, lo and behold, it was exactly the same.
The Lake Toba sample matched up perfectly to John's mystery ash. It had the same high amounts of silica, and it too was 75,000 years old. This was the first time in 6 years John had come across a known sample and a known location that matched so precisely with the mystery ash. It is now clear that Lake Toba lies at the center of a pattern of ash distribution across half the globe. This ash is all 75,000 years old, a date linking it to a moment in the Earth's history when the planet's temperature plummeted and the atmosphere became choked in up to 4,400 megatons of sulfate. There's just one problem. Where's the volcano? Volcano.
Let's climb up here and take a look at this rock. Yeah, I see quartz crystals, I see biotite, and there's ash in here. This rock was definitely generated in a magma chamber, but look at the incredible extent of this. It extends all the way up to the top of the cliff face here, and this represents a tremendous amount of magma. And the really strange thing is this is thousands of times greater than you find at typical volcanoes.
So what could possibly have put this much rock here? There's only one thing big enough to create this much rock in an underground lake of magma, and it's one of the most recent discoveries in volcanology: supervolcanoes. To qualify, a volcano must produce at least 1,000 cubic kilometers of magma in a single eruption. It takes the Mississippi River 2 years to dump the same volume of water into the Gulf of Mexico. A supervolcano can put as much ash and rock into the air in just a few days. These monster volcanoes dwarf even the greatest eruptions of the 20th century.
When you see the footage of Mount St. Helens, it looks like a really awesome eruption. Big, tall ash column. It looks like there's tremendous power there. But that eruption only erupted 1 cubic kilometer of magma. So, as you can see, that's very much smaller than any supervolcano eruption.
Underneath Lake Toba, superheated magma seeped between 2 of the Earth's plates and began to melt the rock above.
We think that it might have taken 1 million years to accumulate all the magma that was beneath Toba.
Magma built up layer upon layer and created a massive magma chamber. The stage was set for an event of unimaginable scale.
I've collected rocks from around Lake Toba for many years. I've also studied ash samples that were deposited around the entire Indian Ocean basin. Although these ashes seem similar to the rocks around Lake Toba, it almost seems impossible that they could have actually come from this area. But when one considers the great size of Lake Toba, its depth, the tremendous relief around the shores, only one conclusion can be drawn. There was a supervolcano eruption here at Lake Toba 75,000 years ago. This eruption created this crater, this enormous crater that we're sitting in. This island here actually slid down off the walls of the crater during the eruption. Now we know that Lake Toba is the site of one of the largest volcanic eruptions ever to occur on Earth.
The evidence has provided Craig with his solution. But where has the supervolcano disappeared to? You're looking at it. Lake Toba is the massive fingerprint this volcano left behind. And the water you see today is just thousands of years of rain. While working on their own research, these scientists eventually solved one of the biggest mysteries of all time.
That, for me, was the eureka moment when we had brought all this chemistry together, combined it with the dating, and it all gave this coherent story of one massive eruption 75,000 years ago from Toba.
But how exactly does one supervolcano cover large parts of the southern hemisphere with 2,800 cubic kilometers of magma and leave behind one of the biggest holes in the Earth's crust ever created? Based on the seemingly random discoveries of a group of scientists over 15 years, we can now take you back 75,000 years to witness one of the greatest volcanic eruptions of all time.
Magma would have been accumulating beneath this area, doming up the entire terrain.
A massive lake of magma continued to grow beneath what today is the jungle of Sumatra, putting the whole landscape under incredible stress.
It certainly would have involved new cracks opening up in the ground.
The roof of the magma chamber, though, began to collapse and sink into the magma chamber. This forced the silica-rich magma out along the perimeter of this collapsing roof block.
Once the eruption started, all hell would have broken loose.
This magma erupted explosively towards the surface, generating enormous ash clouds and generated pyroclastic flows,
which are very destructive and hot avalanches of gas, ash and rock. And of course they destroy everything in their path.
For the next few days, the mayhem continued.
Very high eruption columns. These eruption columns would have reached tens of miles into the atmosphere.
The eruption plume sent billions of tons of ash around the globe. Ash that would end up in John Westgate's lab 75,000 years later.
This would have gone on for 1 or 2 weeks. At the end of this time, what would have been left was a 2-kilometer deep hole filled with steaming pyroclastic flow deposits. Since then, the depression has filled with 500 meters of water, resulting in the landscape that we see today.
Now that they understand the scale of the Toba eruption, scientists are hard at it, trying to find out what a super eruption would do to life on Earth. Key to Toba's power to devastate life are the ash and sulfur dioxide that make up the plume of the erupting volcano. When Toba erupted 75,000 years ago, the Earth was abundant with animal life, but only sparsely populated by early humans. The total world population was only about 60 million, less than 1/100th of the people on the planet today. Any human or animal within a wide radius of the eruption would have suffered a painful death.
Well, if you're close enough to the volcanic eruption, and in a super eruption that can mean thousands of miles away, if you breathe in the ash in an unprotected way, you're breathing in tiny little glass needles. And they get into your lungs, they cause the blood vessels in your lungs to pop. There's moisture in your lungs. The ash combines with the moisture to make a kind of a cement. You basically choke to death.
Sulfur dioxide, a key ingredient in the plume of the erupting supervolcano, has a devastating effect on life by altering the climate of the entire planet.
Sulfur can reach very high altitudes. In the atmosphere, it combines with water to make sulfuric acid, which is a liquid, which forms tiny little droplets. And it's that mist of drops of sulfuric acid that present the veil that cuts out the sunlight, that scatters the sunlight back to space, that keeps the sunlight from getting to the surface of the planet to warm the surface of the planet.
It is this process that gives sulfur dioxide the potential to send the Earth's climate into a nosedive, causing famine and death right across the globe.
Well, based on our present information, Toba had a major role in causing a 1,000-year climate cooling and created a mini ice age that lasted at least 1,000 years, perhaps longer, which could have affected life on the planet, certainly did affect life all over the planet, and could have had a severe effect on human beings at the time.
But scientists disagree about whether Toba really could have caused an ice age lasting 1,000 years. Modern observations have shown that the effects of volcanic sulfur dioxide and ash are washed out of the atmosphere in just a few years. This question is considered urgent enough to have attracted the attention of NASA. They've created a computer simulation to find out how a super eruption could create a millennium of freezing.
In our simulations, the planet definitely cools in response to this super eruption. The cooling is larger than you'd expect just from having the eruption itself.
Drew's model has identified the seemingly harmless mystery ingredient that can turn an eruption into an ice age.
We think Toba could have pushed the planet towards an ice age because the model was able to increase the area covered by snow. So that makes the planet brighter, more reflection, and then even after the volcanic material has fallen out from the atmosphere, the brighter surface can allow the cooling to continue.
Any sunlight that did manage to penetrate the dense cloud of sulfuric acid was immediately reflected back by the snow. It was this that could have sent the planet's temperatures tumbling further. Using the climate data collected by NASA, we can now go back once more 75,000 years and show how the super eruption of Toba may have devastated life in an ice age of its own making. Sulfur dioxide gas reaches the atmosphere, reacts with water molecules, and creates sulfuric acid. This ever-expanding acid cloud is on the move and now covers a vast area over the eruption site. This lethal cloud of sulfuric acid and ash has the potential to kill plants, animals, and much of human life on the planet. The cloud cover has now extended across large areas of the globe, trapping the sunlight. This acid cloud blocks and reflects the sunlight, so although the sky appears almost intolerably bright, little sun can penetrate through it. Vegetation withers and dies. The food chain is disrupted, and eventually animals and humans starve to death. As the temperature drops, the snow and ice cover over the planet's surface begins to grow. This too reflects sunlight rather than absorbing it. The more snow and ice covers the planet, the more sunlight gets reflected. In this way, the cooling spirals out of control, plunging the planet into a global freeze. The advancement of glaciers has begun, and all the while more and more snow crystals reflect any additional solar radiation that is able to penetrate through the now thinning sulfuric acid cloud. The sulfuric acid in the air turns previously lush, fertile soil into a wasteland. Meanwhile, the oceans are cooling. The tiny creatures within them, a 75,000-year-old testament to a disaster of incredible scale. snow continues to fall. In Greenland, over years, it sinks down into layers, and as the millennia pass, this snow is compacted into ice over a mile thick to form the Greenland ice sheet. It only sees the light of day for a second time when dug up by Zelinsky and his team. The Earth's climate systems are still coughing and spluttering, half a century on from the brief but cataclysmic Toba eruption. Some scientists believe this event would have wiped out at least 60% of human life from the planet. Beneath Lake Toba, the subduction zone is still crashing. The magma chamber could still come alive. With 100 times as many people on the planet, the next time it erupts, the effects on our modern world couldn't be worse.
Well, a supervolcanic eruption would affect all aspects of modern life, modern civilization, food resources, climate, water availability. The water would become polluted by the ash. The crops would fail, the livestock would die. Machinery would get clogged by the ash, so that automobile filters would clog. You can't drive. The jet engines on commercial airliners would clog up, and so worldwide air traffic would come to a standstill.
Now that scientists understand how dramatically supervolcanoes can affect life on Earth, they're racing to work out the life cycle of this terrifying natural phenomenon to see when the next one will occur. We are all vulnerable if another supervolcano comes to life. How many of us will survive the next time around? In the early summer of 1988, scientists set out across the frozen desolation of Greenland, looking for the perfect spot to conduct their research. They're here to study the atmosphere and how it changes over time. After journeying across the ice, the scientists find their spot 787 miles from the North Pole. This far north, the ice is so untouched that it contains a record of the Earth's atmosphere stretching back 200,000 years. Throughout history, the chemicals that are in the atmosphere are captured by snowflakes as they form. Over thousands of years, this snow is compressed into layers of ice to form the ice sheet that's over a mile thick. By cutting down through the ice, scientists can obtain ice samples that fell as snow thousands of years ago. When they analyze these samples, they can find out what chemicals were in the Earth's ancient atmosphere. The deeper into the ice scientists look, the further back in time they can go. Climatologist Greg Zelinsky helped reveal the secrets contained in the ice. This remote lake in Southeast Asia holds a secret. Miles beneath its placid surface lies the cause of one of the greatest natural disasters ever. More powerful than anything else on Earth.
The devastation that it caused was unimaginable.
All hell would have broken loose.
Its impact is global, but nobody realizes its true extent until a series of scientists working in different fields at different times all chance upon new evidence. A trail of destruction stretching from the Arctic to the equator. This event may have killed millions. It may even have kicked us into an ice age.
It was like flipping the switch on the global climate system from hot to cold.
But what's really scary is it could happen again. A modern-day eruption of this volcano would bring fire, famine and death to millions of people. 75,000 years ago, it changed the world forever. Now, we can show you how. Few of the people here realize their tropical home could affect the lives of the entire world. Lake Toba lies in the northern part of the Indonesian island of Sumatra in Southeast Asia. It's one of the largest natural features of the southern hemisphere and is clearly visible from space. But Lake Toba is also home to a terrifying mystery. A mystery that lurked undiscovered for millennia. It would take the random encounters of scientists working on a range of unconnected research to bring it to light. In fact, the first clue comes from somewhere that couldn't be more different from this tropical paradise.